Introducing the ISL OptiCPP and its physical principle of operation for measuring pour point and cloud point of petroleum and biofuel products. The cold behavior of petroleum products reflects its fluidity characteristics. Oils that do not flow at low temperatures will not provide satisfactory lubrication. Fuels that become cloudy at low temperature may clog filters and prevent proper engine operation. OptiCPP provides a stable and reliable platform, common to other PAC instruments, that's easy to use and provides real-time results that allow users to evaluate the quality of their fuels and lubricants. A revolutionary built-in cooling system allows testing samples below -95°C. OptiCPP's main components are the electronics, a cooling system connected to a sample jacket that rotates to 90 degrees, and cable-free heads that are attached to the sample jacket and secured with a simple threaded ring. Probe calibration values are registered in the head and automatically read by the analyzer. OptiCPP has 3 status screens that can be accessed with the arrows to the right of the screen. The top run screen is for data entry and shows real-time sample and jacket temperature. The second screen shows real-time test information. The third screen shows real-time test temperatures and detection signal. To run a test, fill a clean and dry test jar with the sample up to the mark. The bottom of the meniscus should be leveled with the mark. The pour point test jar has 2 level marks. The lower mark is used for samples with pour points higher than -60°C. The upper mark should be used for low temperature test, with expected pour points of less than -60°C. Add a cork disc into the sample jacket. Using the gasket positioning gauge, align the cork ring around the test jar and place it into the jacket. Next, place the testing head into the jacket and secure with a small twist of the threaded head ring. To start a pour point test, go to the run screen and enter the operator name, sample ID name, and product or test name. The test is ready to start when the System Ready box has a green check mark and the Start button turns green. Unexpected pour point can be entered to accelerate the cooling down to 9°C above the expected pour point, then switching to slower cooling as outlined by the method. Pour point is determined by tilting the sample at a specified temperature interval. Most samples are tested every 1°C or every 3°C, but temperatures up to 5°C intervals can be selected. When the jar is tilted, the detector looks for movement at the surface of the liquid. As soon as the liquid moves, the tilting stops, and the jar is moved back to rest position until it reaches the next lower temperature. The end of the test is achieved when the jar can be tilted at an angle of 90 degrees and the sample does not move for 5 seconds. The pour point is the lowest temperature which the product continues to flow. A cloud point test is similar to the pour point test. A cloud point uses a test jar with a mirrored finish at the bottom. Fill the cleaned and dry test jar with the sample up to the mark. Remember that the bottom of the meniscus should be leveled with the mark. Add a cork disc into the sample jacket. Using the gasket positioning gauge, align the cork ring around the test jar and place it into the jacket. Next, place the testing head into the jacket and secure with a small twist of the threaded head ring. To start a cloud point test, go to the run screen and enter the operator name, sample ID name, and product or test name. As the sample cools down, wax crystals start to form near the bottom of the test jar. When the crystals grow big enough to interfere with the light reflecting from the bottom of the test jar, the test stops, and the temperature is recorded as the cloud point. Easy to use, reliable, sensitive, accurate, quiet, dependable. Visit our website for the latest product updates or contact one of our experts.